Hi, so let us welcome the associate of impulse into the limelight. So the associate of impulse is actually momentum. Why do I say that? And that's because if you have a body on a plane and then you apply a force and that force take a particular time to actually create an impact on the body. Now, just as you might know, that's a particular mass, then this is actually called what? F times T is actually the impulse. Okay, good. So, and that impulse creates what we call change in position of the body. And so the body begins to move with a particular speed, V. So, that means it is impulse that actually creates motion. Okay, but then what is momentum? Momentum is defined as the product of the mass of a body by its velocity. So that means V multiplied by M gives us momentum. So momentum is represented by P, as you can see here, is represented by P. So we have P equals mass times velocity. So that's momentum. All right, good. So if momentum is mass times velocity, that means that the unit of momentum is actually mass is measured in kg, then mass is measured in kg. Let me write that here. Mass is measured in kg, then multiplied by velocity is measured in meters per second. So hence momentum is actually kg meters per second. So that is the unit of momentum. And momentum is a vector quantity. It's actually a vector quantity. It has both direction and magnitude. All right. So what I want to bring your attention to again is the fact that you see, if you have a body like this and it's on a plane, now you have an impulse acting on the body that creates momentum on the body. What that means is that the impulse is actually the same as the momentum. So that means the amount of impulse that is reacting on that mass determines the momentum of the mass. And actually they're actually the same. So change in momentum is equal to impulse. All right, change in momentum is equals to impulse. So let me just help you with that. Okay, so what that means is that when object changes position, let's say it's at U, let's say at rest, let's say the body is at U initially, then it moves with a speed, particular speed V. Remember, the mass is still the same. So what's the change in momentum? This is mu, this is mv. All right, so the change will be this minus this. So the change in momentum is actually mv minus mu. So that means I'm saying that impulse is the same as change in momentum. So that will be impulse is ft equals mv minus mu. And that leads us into talking about the second law of motion, which was given by Sir Isaac Newton. All right, good, by Sir Isaac Newton.